Thanks everybody for joining, and today's session is on AFCIs, arc fault circuit interrupters, and that's the presentation. So welcome, and I'm excited about this session on 210.12. Good afternoon, Jack. Great to see you here as well. Thanks everybody for joining and dialing in to the program. We're going to be talking about the arc fault circuit interrupter and all of the great things that it has to offer, and the National Electrical Code and all that good stuff. So I'm hoping we're going to have a decent program today. We got 2 hours of remote communications going on. Please remember to use your chat. If you're on WebEx, use the chat on WebEx. If you're out on the interweb, the good old YouTube, please use the chat window there. And I see people are dialing in. When we register on Menti and take the quiz, when do we receive an email about the PDHs? I send that out to everybody. I did send yesterday's out. So if you were, Jamie, if you were in yesterday's event, you should have received it. If not, please send me an email, send me a note. I will get it to you. But I'm just going by that spreadsheet. So if you, and then I did have a couple people who did not enter their email correct. I got it bounced, and I'm using the exact email address that they put in there. So I'm sure someone's going to be complaining about that, but I can only send it out to those who typed in their email correctly. All right, so today is arc fault circuit interrupters. And the code, all of their phones are on mute. Please remember to if you watch that little symbol, if you are on WebEx, there should be a little symbol there just to make sure we don't have any issues. I will try to find you as soon as I can if you accidentally unmute yourself, but I can't make big promises. Okay, so we're going to, as usual, I want to go into the quiz results. That means that I need to queue up. The quiz. There it is. Yep. All right. Okay. So first question. First question is: select the devices below that detect arcing and sparking that causes electrical fires. Your options were GFCI, AFCI, GFPE, thermomagnetic circuit breaker, and throw me a bone. Now, I did. This was the bone. This was, I think, this was the one that was supposed to be the bone. And 162 respondents said the AFCI. That is true. Now, those 25 who said GFCI, I am thinking that part of me is definitely in your ballpark there. I think that GFCI can do some things for electrical what do you call it, arc detection, because you think about an NM wire. NM wire has a ground in the middle. So if I have a fault that goes from inside of that NM wire, then I have a good chance of going to ground fault. In fact, in the early days of branch feeder, we had GFPE, and a lot of the breakers that we got back, and where we had tripping and where we found problems, they usually started as a ground fault, especially in NM wire. You know, obviously in SPT2, which are those just the two conductor that don't has it just has hot and neutral. You know, obviously in those cases, I don't have the ability to detect ground. So the answer to this one, obviously, was AFCIs. Oh, Luis Diego, Luis, I will get you the codes. Don't worry. So I got you. You're documented. Send me an email. I will get you those codes. Okay. So second question. Those are your AFCIs that are on the market today. So AFCIs provide our arc fault protection. There you go. Thank you, Bernard. Sharing information. That's what it's all about right there. Okay, so you ready for this one? An AFCI device that has both GFCI and AFCI is called what? Combination, dual purpose, they don't exist, or you just don't know. Okay, so this is how it came in so far. And remember, you could go to Menti right now and enter 149809. If you're on this call and you did not take the quiz, you don't have to, you didn't miss out. You can always go on to menti.com, enter 149809, and enjoy the fun. So an AFCI device that has both GFCI and AFCI is actually called a dual purpose AFCI. It's not a combination type. That is a very big misconception that is out there in the industry, and I don't think that I don't like the term. I don't like combination type AFCI. I wasn't around when they came up with that, and I probably, if I was, I probably wouldn't have been able to change their minds. But we're going to talk about what a combination type AFCI is and why it's called that, but that is not a good terminology. Here's the faceplate of one of those devices. You'll notice on this that you have dual purpose and combination type on that faceplate. So we have both of the terms represented on this one. So this tells us that this device is both an AFCI and a GFCI, and it is the combination type AFCI device. And that's all required to be on the label. Now, if we don't like, I can always get the complaint, boy, Tom, the labeling and lettering on these on your devices are so small, and why is it so small? Well, it's so small because as part of the listing requirement, I've got to put all of that information on there, and we debate and argue from a standards perspective. What is it exactly that we want it to say? And remember, that has to be viewable through the dead front, right? So with that cover on, that's a challenge to get all of those words on a little spot. So yes, you're going to have probably a little magnifying glass if you're like me and you can't, or use your phone, take a picture of it and move it up front. But so these devices exist. The dual function or dual purpose, I've heard them called dual function, and I will use that interchangeably. I mean, I call it dual function, I'll call it dual purpose. Technically, it is the dual purpose arc fault and ground fault. It's the combination type does not mean arc fault and ground fault. Dual purpose. Now you'll notice here too, and I was just looking at the information, they have on there that it is it provides over voltage protection, which I think is pretty cool. And that there basically helps solve or preserve the electronics inside. So if I can clear the an overvoltage, just like Surge does, but I'm basically providing some protection for that device internally, I can save you having to replace it. Continuous self-testing of the electronic components. We talked about self-test a little bit yesterday. On GFCIs, we do have self-test capabilities on AFCIs as well. So, when you have the same group of engineers or a similar group of engineers, especially when they sit close together, it They share information. I'm just going to check my audio here if I can. I had somebody say they can't hear me that well, but hopefully I'm coming through loud and clear. And let me know if you can't in the chat window there. It's an open mic. I might have an open mic. So here's what I'm going to do. I'm going to pause. I'm going to stop sharing real quick. I'm going to make one little change. I'm sorry? There we go. Thank you. Here's the other thing I'm going to do. Options. At the chat, import mode, content sharing. Okay, so let me share back out again. It was perfect. I'm glad to see that's where chat's working. Okay, sounds good now. Thank you, Robert. Okay, so I am going to do two things here. I need to open two windows so that I can see what's going on and bring them over here. I'll have to edit that out of our YouTube, but there we go. All right, thank you for the notes. I'm just keeping my left eye on the chats and my right eye on the video stream. These devices are connected. So if you think about the GFCI and AFCI, the dual-purpose device, you wire them just like you would wire anything, and it's providing GFCI protection for anything that's downstream and anything that's connected downstream, including, I mean, it protects everywhere downstream. All right, so now we are going to do the next one, the OBC AFCI. OBC AFCI is a receptacle AFCI, a large AFCI, and AFCI with GFCI. What's our pleasures? Let's take a look at what the respondents said. Wow, okay, this is really good. So we have 53 people that said that or 53 who are just not sure about what the OBC AFCI is. We're going to talk about that a little bit. And AFCI with GFCI, nope, those 20 didn't quite get that. It's a receptacle AFCI. So we've got a pretty good majority of everybody who's out there who understands that the AFCI, OBC AFCI, and it's OBC stands for Outlet Branch Feeder, Outlet Branch Circuit type AFCI. That's what it stands for. So that is a receptacle type AFCI device. It is the outlet branch circuit. It's the outlet branch circuit type AFCI. It provides parallel and series arc detection downstream. It provides series arc detection on the supply circuit. That's basically what the OBC AFCI is. Okay, so enough said about that one. The combination type AFCI is one that detects series arcs and parallel arcs, or detects parallel arcs only. Now, I think I messed up the question, but it should have said extends series arc detection to the connected cords, has series arc protection, or you have no clue. So let's take a look at what the respondents said, not at the answer. A combination type AFCI is one that detects series arcs and parallel arcs. 117 people said detects series arcs and parallel arcs. 26 didn't have a clue. 8 said has series arc protection, and only 22 said that it extends the series. It should have said just series and parallel. I mean, it does have series and parallel arc detection to the connected cords. But technically, it only extends the series arc protection to the connected cord. That is the right answer. So the 23, you guys can stand up, run around the room a little bit, high five if you have, well, remember, 6 feet away. So don't get too close to do the high fiving, air five. You guys got it right, or gals got it right. The 120, they thought probably, I mean, this is how we always teach it. Industry in general will say the combination type is series and parallel, and the branch feeder type was just parallel. Technically, that is not correct, but it gets the point across. So, but I'm going to walk you. I'm going to walk you through. So the right answer was the extends. I'm going to walk you through some of the UL 1699 testing to help you understand what each of these devices does. I think it's important to understand what you're getting and what level of protection that you really have in these items. Okay, so there's your typical circuit. If you have an AFCI circuit breaker installed, you have protection of the installed NMB wire. So this is your, we call this portion of the conductor right here your home run circuit, because that's from the breaker down to the first outlet. That's your home run. These connected cords quite often will have, quite often it'll have only like 2 conductors in there. And so that will be only your hot and a neutral. There's no ground. But quite often, if you have a third prong on whatever your appliance is, then you more than likely have a ground in there as well. So that would be your connected. And when I say SPT2, I mean a 2-conductor cord with a hot and a neutral. So the AFCI breaker protects everything that's connected. Okay, and we'll walk through the level of protection. So here's a shot of the UL standard and what it provides, and from an arc detection perspective. So I'm focused right now on arc detection because that's where the difference lies between a combination type AFCI and a branch feeder type AFCI. And I'll have you note that the only test that is different is the carbonized path arc clearing time test. It has all of the other same tests as the branch feeder. It just does not have, but it has one additional test of the carbonized path arc clearing time, which you'll probably going, that doesn't make sense. What is that? I'm going to show it to you, and I'll help you understand that the combination type AFCI, the one key thing that you're getting in addition to the branch feeder is series arc only detection in the connected cords. So series and parallel terminology are not technically accurate to describe the differences. We use that all the time. That's basically an industry practice that we all say, you know, branch feeders give you parallel and combination types gives you series. So, and then the whole discussion becomes, what is series and parallel? I mean, if you're from an engineering perspective, we know we just don't say series. We have to say in series with what, or in parallel with what. And what we're talking about there is in series with the load or in parallel with the load. So if when we think about a circuit or so if this is this would be a series circuit and my arc would be, say, at point A, this would be a parallel. So if I think about a conductor, think about a standard conductor where you have hot, and this is really difficult, and neutral. If I cut across here, that would be considered in parallel with the load. If I break this conductor in the middle and I cause an arc in series with the load, That's basically what we're talking about from a series arc perspective. So you have a parallel arc and a series arc. Now here's the big difference between those two. When I have a parallel arc, remember, now hopefully most of everybody who's on this call was on my call on Monday, because we talked about short circuit calculations, right? And what did we say when we have a circuit and we have a short circuit? We have a hot conductor going out, we have a neutral conductor going out to a load. Remember, we drew this out and we showed the impedance of all the different conductors, right? So maybe there's terminal blocks and all of these were resistances. And we said if the normal load current was a very low value because it was whatever the load is drawing, but the moment I had a short circuit, the load was taken out of the picture, and now my circuit current is much higher. Well, same philosophy here. If I am in a parallel nature, I have my hot and my neutral, and I cut this down. We call that a high energy arc because I've taken the load out of the picture, I've shortened up my circuit, and I can have higher fault currents, even if that's the end. And what they found was that if you go all the ways out to the last receptacle, they did a study, UL, and I think it was UL and NEMA members and whatnot did a study. We went into a lot of different homes and we measured the available fault current at all of the different receptacles inside of a home, and they found a number that beyond which you know that's like the lowest available fault current that you can have. So that is the number that is in the standards with regard to testing from a parallel arc protection perspective. Now on a series arc, when I have an arc that is occurring in series with the load, because the loads are still in the picture, I'm going to be drawing lower current. And I need to detect that. So my normal current that I'm detecting is not a higher value of current. It's actually a lower value of current, like around 5 amps. So I have to detect a very low series arc to be able to provide that level of protection. So in any case, that's basically what we're talking about from a series and a parallel perspective. Probably clear as mud. Now, so there's 3 basic tests that we do on all of the AFCIs. We do a point contact test, and I'm going to show these for you. A carbonized path arc interruption test, a carbonized path arc ignition test, and then the 4th test was the one that was added for the combination type AFCI. And I'm going to show you each of these to help you understand how we do the test. And then I'll give you some insight on how we, from a manufacturer's perspective, how we pass the UL standards to achieve those. And maybe that'll help you understand the technology a little bit more. Okay, so the point, I call this the guillotine, this little thing up here. And if you recall back in the day, man, when I first went into residential products, I was a product manager for the AFCIs and the GFCIs, and I was going across the country. I called it cut and wire, and I would sit there with a guillotine. Eden wouldn't let me do what we did back then, because we've changed a lot from a safety perspective in our organization, as I know everybody has, with the awareness of electrical safety. But in any case, we used to take an SPT2 cord, and this guillotine was of a certain material that was non-conductive. There was a standard razor blade in here, and then we would lower this level and tease it and cause an arc, and I have a video of that, I'll show you, and cause an arc on the SPT2 cord that would not trip a thermomagnetic breaker, but would trip an AFCI, because this is one of the tests. Remember that current I told you that we measured all the ways out at the end of the run for the last receptacle? 75 amps was that key number that we use. So we have to detect a parallel arc all the ways down to 75 amps. So the parallel arc will testing, we will even conduct it on an SPT2 cord, so you have arc protection and detection parallel perspective on the connected cords of an SPT2, and you have it on the NMB wire. So you think about NMB, if I did the same thing on NM wire, you have 3 conductors in NM, right? We'll have a hot, we'll have a neutral, and we have the ground. And you'll notice the placement of that ground is in between the hot and neutral. That's going to be very important when we get to understanding how we pass one of these other tests, or how we used to pass it. That's one of the standard tests. So we do this test on NM wire and on SPT2. One of them has an equipment grounding conductor, the other does not. And that's at 75 amps. So then we do another test, which is a carbonized test, where this is NM wire. Okay, so this is your NM. That is your yellow sheath or your white sheath, and the ground is here. Your hot is here. Your neutral is there. And what we do is we do an insulation cut, and we hit it with a higher voltage, then start some carbonization, and then we watch it go. Now, we do this at 75 amps and 100 amps because that's the parallel arcing. Because remember, you're taking the load out of the picture, and what we did was we measured in residential homes. We found that 75 amps is pretty much the lowest available short circuit current. So when you take the loads out of the picture, you have to do an parallel arc detection at 75 amps. And we do it via the guillotine, and we do it via this carbonized path, right? And then we'll also remove that ground. Now this is a 5 amp series arc that is performed by the branch feeder AFCI and the combination type, but the branch feeder AFCI, which is no longer permitted in the National Electrical Code, was one of the first ones that came out. You were required to do a series arc detection on NMB wire. And look what we did. We cut just one of the conductors in there. We would cut the insulation, cut down through just that hot conductor, and I believe we do the neutral as well. We cut down through one of those conductors, we wrap it all back up again, and you cause a 5 amp arc, and the branch feeder AFCI did have to detect a series arc. Now here's how we did it. And you know, all of the AFCIs on the market at that time had ground fault protection of equipment, GFPE, at some level. Each manufacturer had a different level for whatever reasons. I believe ours was at 30 milliamps because ours was the only one that was a UL 1053 device as well. We had, our branch feeder was UL 1053, UL 1699, and UL 489. So you have, when this happens and you carbonize this, where is the arc going to go? It's going to go directly to the equipment grounding conductor that's in between the hot and the neutral. And so what we would do to pass this test at 5 amps, a series arc test at 5 amps in NM wire, we all put GFPE in our devices, and we detected that, and we were able to pass this test with ground fault protection of equipment, because if you damage one of those conductors, it is going to that grounded conductor. So, or the equipment grounding conductor. And eventually it'll go to the grounded conductor. But in any case, that's basically how the branch feeder worked, and the combination type does the same thing. So far, we have the guillotine, right? We have the guillotine, which is a parallel arc at 75 amps. We have the carbonized path test, which is at 75 amps. And then we have this series arc down to 5 amps. The branch feeder and the combination type does all of that. And then finally, you have the last test, which is the new test that was added for the combination type AFCI. And what you're looking at here, and we could, this is your SPT2 cord. So we take a standard SPT2 cord, and you cause a cut in that cord, you wrap this with some cotton and all of that good stuff. And you know, if the cotton didn't burn, then you cleared, then you had a successful test and you passed the standard. But you'll notice the big difference is there's no equipment grounding conductor. There's no EGC at this location. So I can't rely on ground fault protection of equipment for an SPT2 cord to detect a 5 amp series arc in a connected cord SPT2. And that was the challenge for the design engineers on these products. So if you look at all of the tests, the point contact test, your AFCI, everything that's in blue, all of these items and these two items here for the installed NMB has point contact, which is a parallel arc, carbonized path, which is a parallel arc, and the carbonized path arc ignition, which is the series arc 5 amps. So do you also have 1 and 2 on the connected. So that's your parallel arcs for the branch feeder on your connected cords. And then we added the SPT series arc detection for the connected cords. So that is what you get when you are buying a combination type AFCI. You're getting protection of 2 conductor SPT2 cords that are plugged into a receptacle going to a load. If you don't have, and at 5 amps, if you don't have a combination type and you have the older type branch feeder, then you'll still get a parallel arc detection in that SPT2 cord. You just won't get the series arc 5 amp test protection for that device. I hear somebody talking, so please check your mutes. Jorge Morilla, I'm going to find you, buddy. Hopefully these are alphabetical order. Okay, you muted yourself. Thank you very much, Jorge. Okay, so that's what you get. It's like a box of chocolates. Dual function. Remember, we talked about this already, so that's not the combination type. Combination type gets you series arc protection of an SPT2 cord when it's plugged into a receptacle. A dual function gets you AFCI, and again, that's dual purpose. I was using dual function. This slide is probably before they actually put the line in the sand and called it a dual purpose. Dual purpose device, 943 is a 943 device, not a 1053 device. Remember, if you were in the call yesterday, you understand what 943 is people protection, 1053 is equipment protection. It's 4 to 6 milliamps, 5 milliamp ground fault protection. AFCIs that carry UL 1699, again, dual purpose. Oh, there we go. I got the right word there, dual purpose. All right, so extends the series arc detection to the connected cords. All righty, I'm glad we got through that one. Next question. The first book that had an AFCI was, drum roll please. So, for those of you who answered the last question, the 122 of you have just come away with hopefully a little bit more knowledge than what you came in with. The first NEC book that had an AFCI was, we're all over the board here. This is interesting because the first one was actually the 1999 National Electrical Code. That's how far it goes back. The AFCIs have been around for a very long time. Look at that. I love that. This is what I call the horse races. As soon as you put the answers up, people want to start answering it. 50 of you said 1999, which is a good thing. It's been around since 99, and if you looked back at the 99 code, what you would learn is that the requirement was around the receptacle, and it was the receptacles in a bedroom, just the receptacle outlets in a bedroom. And then it was the 2002 code that said, no, they want all of just the branch circuit going to bedroom outlets needed to have GFCI or AFCI protection. And the reason that we had that was because they realized that it's not just the receptacles that are creating some issues. It's the oops. It's not just the receptacles. It's any of those wires that are installed behind the walls. So the answer to that is 1999. It first went in for bedrooms, and it had an enforcement date, I believe, of 2002, because there was only like one or two manufacturers who had that out at that time. And then when it became effective, it became required for the bedroom circuit, not just the receptacle outlets, but it was any circuit that goes into that bedroom or any outlet. All right, so 1999 was the right answer on that one. AFCIs are not required where GFCIs are required. True or false or not sure? Let's see what we got. We're doing good on the stream. We've got 105 people up there. So the first NEC book that had an AFCI was that, so we're moving on. AFCIs are not required where GFCIs are required, and I would think about 137 of you guys and gals were probably on the call yesterday, because we did chat about this yesterday, and we talked about it. So that is false. And let's do this. I'm going to help answer this question. I'm going to, oh boy, that I'm going to call up the NFPA website. We're going to look at the National Electrical Code, which I already have opened here. And remember, the NEC is no longer do you have a PDF. You can get the book, which I highly recommend, always having a book handy. You can get the online service, which I am showing you that capability right here. What's nice about this, you can search in here, you can view the code, and if I'm going to go to 210.12, there it is. So 210.12. And the question was, is it true or false? AFCIs are not required where GFCIs are required. So what you have to do is look and say, what does the language of 210.12 say? Arc fault circuit interrupter protection shall be provided as required by A, B, and C. And what you see is all 120 volt single phase 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling unit, kitchens, stop at kitchens. GFCIs are required in kitchens. So we do have a requirement where you have an AFCI requirement and you have GFCI. So you have kitchens. You wouldn't have GFCI in family rooms, dining rooms, living rooms, parlors, libraries. Parlors? I don't know. You might have a wet bar in there. Dens, bedrooms, sunrooms, rec rooms, closets, hallways, laundry areas. Yep, we have GFCI protection in laundry areas. And then similar rooms. So we've got kitchens where you would definitely have GFCIs and laundry areas. Now the challenge, I hear a lot of people say, well, how do I meet that code requirement? How do I meet that code requirement if I have an AFCI that's required and GFCI that's required? How am I going to provide both of those technologies? And if you still like the local resetability from a GFCI perspective, you could put a GFCI receptacle downstream of an AFCI circuit breaker. No compatibility issues there. The challenge is, if you look at the language for GFCIs and AFCIs, they have to be readily accessible. So if you have a refrigerator, say, that would need to have GFCI, and if you put a GFCI receptacle, it would be behind the refrigerator, you could put the receptacle, the GFCI protection, on a receptacle that feeds that receptacle. Because remember, we learned yesterday, and we learned a little bit today, that these devices feed downstream from them. If you say, I only want one receptacle and that's for the refrigerator, I don't want anybody to accidentally plug anything else in on that circuit because it's a dedicated circuit, then you could put a blank face GFCI, which doesn't have the outlets where you can plug anything in. You just have a push to test button on the front, and then you could land that in a readily accessible location. that would be an area near that piece of equipment that you can have local resettability and know that that's for the kitchen, for the, say, the whatever it is. It doesn't have to be the refrigerator. It could be anything. So there is value in being able to reset something. And you'll probably have more ground fault issues from an unwanted tripping issue or not unwanted, but thank God it opened issue more frequently than an arcing fault, I would think. So in any case, you could do that and have local resettability by using those types of devices. Or you could put both of those technologies, AFCI and GFCI, in the circuit breaker. So there is a little bit of a challenge when you have an area in the house that requires both AFCI and GFCI, because you've got to get somewhat a little bit creative about being able to provide both of those protections and meet the requirements of readily accessible. All right, let's go back and take a look at what the survey results on that was. Again, 142 of you said it correctly. Okay, so let's move. And we already did the look at 210.12. Okay, so an AFCI device needs to have an equipment grounding conductor to work properly. Let's take a look at the survey results on this one. I think we might be. Go. 5. An AFCI device needs to have an equipment grounding conductor to work properly. 185 respondents now. Thank you for that last minute vote. And I still haven't told you the answer. 112 said false, 56 said true, and 17 aren't sure. So the 112 is correct. Those guys, you do not need an equipment grounding conductor to work properly. You have to remember that we talked about the SBT2 cord example, right? So from a technical perspective, you have the SBT2 cord, which can be protected by an arc fault from parallel arcs and series arcs. So you get both of those protections even in an SBT2 cord downstream. I do not need an equipment grounding conductor to be able to detect an arcing. So a common question I get with regard to AFCIs is, like, say, in existing homes, if I have an older home that has knob and tube wiring, for example, can I use an AFCI circuit breaker in those applications? Absolutely you can, because I don't need that. I need a hot and a neutral. I don't need that equipment grounding conductor. The challenge is whether or not you have ground fault in that device, because here's what they used to do back in the day is they would share neutrals. You know, my brother's house, we were putting AFCIs, and I got some pictures of from his house. We had some tripping issues when we installed AFCIs inside of his home. We had one device. As soon as you turn the light on downstairs, it would trip. And Bruce Terhorst was our guy from Eaton who went out to the job sites and whatnot. So he came out and he gave me some pointers. He looked at it and he walked down to the basement. He went to the first gang box that had like 5 or 6 light switches. He goes, let's take the cover off of that. We took the cover off. He pulls all the light switches out, and sure enough, they had multiple circuits coming in, 2 circuits coming into that one box, and all they did was just wrap all of those neutrals together. We separated the neutrals, put them where they should have been put, and separated both of those branch circuits, and the AFCIs worked fine after that. So AFCIs are going to find that if you have ground fault protection in there, anything upstream, you can't share neutrals downstream. On a single pole, you can have a 2-pole breaker, AFCI or GFCI. But that's an important aspect to remember. AFCI device does not need to have an equipment grounding conductor. Okay, so how about the next one? A GFCI receptacle cannot be placed downstream of an AFCI receptacle, and I think I answered that one already. Let's take a look. GFCI receptacle cannot be placed downstream of an AFCI circuit breaker, and the answer is false. Good. 158 answered that. You know what? Here's my rule. If the majority of you get it correct like that, I'm moving on because you know what you're talking about. So how about this one? So this one, I had an email, I think it was David. I got an email from you last night or this morning that said, question, I think it was last night because in his email he said, go to bed. Because he had a couple of items in my questionnaires. You know, these guys are smart, you know, which is really good. And they keep you on your toes. And I made my quiz last night. So AFCI protection cannot be placed on a smoke detector circuit. There is a difference between smoke detectors and smoke alarms. Now, I'm going to see what everybody said. Let's do a quick look at what people said. A GFCI receptacle cannot be placed downstream of an AFCI. That's not the one we wanted. AFCI protection cannot be placed on a smoke detector circuit. 55 said true, 95 said false, 33 said not sure. So let's talk about this one a little bit, because I think once we get through the discussion, we can come back and look at these. Now remember, there is a difference between a smoke alarm and a smoke detector. Smoke alarms are self-contained. This is what you would see inside of a house. And I know we always use this word interchangeably. I'll call them, you know, smoke detector went off, or sometimes we just call them smokes. You know, how many smokes do you have in a house? Or I need, I need 3 smokes for my house. And so one is an alarm and one is a detector. And the detectors are those devices that are not self-contained. They are typically a part of a system, like a fire alarm system, not a smoke alarm system, a fire alarm system. And so if I go to 210.12, there is an exception where if you have an individual branch circuit to a fire alarm system installed in accordance with 760.41b or 760.121b, and you have that installed in RMC, IMC, EMT, so they tell you you need to protect that circuit with something of substance that is substantial, and then you do not need to have AFCI protection. That's the exception that is in 210.12. I was sort of going there with my question. I meant to say smoke alarms. I used smoke detectors, but that's okay. And that could be why we got a little bit difference of some of the answers. So I'm going to give you some forgiveness there. I wasn't as clear as I probably could have been. Now, there are some resources, because this is a question that I get frequently, especially as you go through state adoption. People have really good, valid questions and concerns. When you have a life-saving piece of equipment like a smoke detector or a smoke alarm system, etc., those are, you want to make sure that they're functioning and operating. So the smoke alarms that are found in residential homes are not included in the exception because it says a fire alarm system. A fire alarm system is different than a smoke alarm. So, but you do have to check local laws, because I believe, I don't know, I know back in the day there was some exceptions. I think all of that has gone away, primarily because NEMA did worked with industry to dispel the myths associated with the AFCI and the compatibility. There's been a lot of work that has occurred around compatibility with different products and solutions, and smoke alarms was way early in the branch feeder days, and typically doesn't come up that much anymore. But I do have a reference for you, and I will say that I'm going to open up. I will open up this PDF document. I don't clobber my connection again. But let me bring this over here. This is a NEMA document that's available online. I just searched for it. I was looking for the website, but I downloaded it. So it gives you a little bit of the background. It talks about the NEMA position on compatibility between smoke alarms and AFCIs. Again, they talk about NFPA 72, what the purpose of AFCI protection is there. And there were cases where there were fires detected or fires that occurred in residential homes on the smoke alarm circuit. So that is, that circuit's just because it's dedicated to bringing awareness of a fire, it doesn't mean that those conductors aren't susceptible to that. So AFCI and smoke alarm, they're compatible. There were no issues, no tripping of the AFCI during normal operation or during alarm condition. So they did some testing. They talk about that they're supplied through 2 different circuits and things of that nature. So in any case, there's a good reference document. I'll put a link to it from a YouTube perspective on the website, on the YouTube website, so you can download that. But that's a good resource for you. The other thing I'll point out is I think I do this later on, but I'm on it now. Might as well talk about it now. So there's a website that you can go to called AFCIsafety.org. And it's a really good resource that I would hope everybody understands and knows it is available. There's a task group at NEMA with all of the manufacturers of, this is the circuit breaker side of the family. The receptacle family has a similar site. But this is a really good resource, an important resource for you, because there's a lot of information up here that I'm talking about in this presentation about what AFCIs are and how the AFCIs help reduce fires. They have homeowner information that if you're an electrical contractor, you can share, reporting information. There's some nice videos up there on a demonstration, a virtual demonstration. We have some good considerations from a state adoption perspective, case studies, fast facts, white papers. There's some good white paper information, tips. There's a UL training course, a link to a UL training course. So if you have questions about how do I troubleshoot a circuit that's tripping, we created in cooperation with UL and UL University a training course that you can take. We have information for AFCIs because homeowners want to understand this technology, especially if if the technology, again, it's an unforgiving technology. If you're finding problems, especially in an existing home, that's normally whenever you retrofit into an existing home, that's the area where you'll find problems. It's good to educate the homeowners on what it is that they're installing in their home. And there's some multimedia information there. I'm going to come back to this website again, but AFCIsafety.org is an important resource for the industry. I'll come back to that as we move through our discussion. So let's go back to the quiz. Might as well, right? Okay, so the branch feeder AFCI does not provide series arc protection. I think we probably dispelled this one already. The answer to that is false, because the branch feeder did do series arc protection, but let's see what everybody online said. They said AFCI protection cannot be placed. Oops. They said, wait a second. Branch feeder AFCI does not provide series arc protection. That's false. Where's that question? I think I skipped one. I did. All right. Well, we're going to do the next one then. It's talking about a shared neutral. If you run a shared neutral circuit, you cannot use an AFCI circuit breaker. 81 said true, 92 said false. Shared neutrals. Think about it. If I have a shared neutral, what's the issue with a shared neutral? I have 2 hots and 1 neutral. And the big issue typically with shared neutrals is that if I have ground fault circuit interrupter, and if I take two single pole GFCIs, I can't put those together with a handle tie because all of that current has to come back through that donut. We had that discussion yesterday. So what is the right answer to this one? I would do is I would probably go out to a manufacturer's website, because if what do we do on GFCI when we have a shared neutral? We use a two-pole GFCI, right? Because inside of a two-pole GFCI, we have the ability to manage the current going out and coming back. So let's take a look. There's a catalog for a two-pole AFCI. We click on that, download a PDF, and lo and behold, we have a two-pole combination type AFCI. So yes, they exist. Two-pole combination AFCIs not only continuously monitor arcing conditions, reducing the risk, they also provide protection for existing circuits using shared neutral, home run, or renovation applications. So there's no excuse. If you have a two-pole, if you have a shared neutral application, you can definitely provide protection for that circuit. So you're looking for a two-pole AFCI. Now, if you have, and I don't recommend it, but if you have two single-pole AFCIs, here's the challenge. If you have two single-pole AFCIs and you want to put a handle tie, even if, because it's a combination type, so here's what happened. Remember in the branch feeder days, they all had GFPE. When we came out with the technology for series arc detection in an SPT2 cord, we realized, I don't need ground fault. And that's an added CT, that's an added cost to the device. So a lot of manufacturers pulled ground fault out of their combination type AFCI, and they provide series and parallel arc protection for everything, even including the SPT2 cords. Now, when they removed that, that was the deterrent from slapping two devices together, because you removed that deterrent, because GFPE is what would make it so that you can't share a neutral with two devices and put a handle tie on it. So now you have, okay, I don't have ground fault in there, and I'm going to slap these two devices instead of buying a two-pole, and I'm going to put a handle tie. Well, here's the issue with that. Those devices are rated at 120 volts. So what happens when you take two 120 volt rated devices, put them next to each other and put a handle tie? The moment you put a handle tie on two circuit breakers that are rated for 120 volts, you now are applying those two breakers at 240 volts together. And that is ungood. So you can't simply put a handle tie on your breakers. You have to look at the breaker and see, is it rated 120 or is it rated 240/120 or 120/240? What is the rating of that breaker? If it's slash rated, then you can put a handle tie on it. If it's not slash rated, you cannot. Always go back to the rating, and then also call the manufacturer and help them understand what you're trying to do with that product and make sure it's legal before you get an inspector out there who's going to go, you're out. So that's an important thing to remember. Okay. All right. So let's see how I screwed up the quiz here in my PowerPoint. That was that question. Go back to. I think I have one more question. So I'm going to move this back this way. I'm going to go back over to my quiz. Find my quiz. Bear with me. Here it is. I love when you guys have patience with me. Here we go. The branch feeder AFCI does not provide series arc protection. See, that's the one I was looking for. The branch feeder AFCI does not provide series arc protection, and the answer to that is false. And because it does provide series arc protection for the home run circuit, not SPT2 cords. So we already went over that. 57 and the 18. Hopefully, you guys are now up to speed. So, and that was fun, wasn't it? It was fun for me. Okay, I don't know about you guys. It was fun for me. So thank you for playing the social distancing network. Now we're going to get into what an AFCI is, and we're going to a little bit more what it does, what the code requirements are. So hold on to your seats and let's get ready to go. So if we go to Article 100 in the National Electrical Code, we have the definition of what an arc fault circuit interrupter is. It's a device intended to provide protection from the effects of arc faults by recognizing characteristics unique to arcing and by functioning to de-energize the circuit when an arc fault is detected. That definition is owned by Codemaking Panel 2. I don't believe it's changed all that much over the years. It's pretty much been the same because its function is to detect arcing and sparking that a standard thermomagnetic breaker cannot. And the reason we have that is because a lot of people were looking at electrical fires and saying, well, wait a second, I'm protected by a thermomagnetic circuit breaker, and apparently it's not doing its job. So the AFCI, it's important to realize it detects what the thermomagnetic circuit breaker cannot detect. And I like to, I'm going to call on an old friend of mine to help us understand that.
There's another phenomena, though, when two wires come together just momentarily and you have a little flash, a little spark, and as soon as they touch, they'll separate again and a little molten copper will go flying. That whole process is so short that a conventional circuit breaker doesn't see it, doesn't know it happened. That's called an arcing fault.
Yes. So that is an arcing fault is something you got to remember that an arcing fault is something that a thermomagnetic breaker cannot see. This was a video that was sent to me of an arcing fault that was occurring at a staple. It's a little bit blurry, but what they're going to do is they're going to shut the lights off in this video, and you're going to see the glowing connection of where that staple has penetrated and caused an arcing fault inside of that equipment or in the circuit. This was at a joist stud. So this I wish I can remember who sent this to me, but it was a fantastic video of a real world problem. The thermomagnetic circuit breaker on this circuit is not opening, and the reason is because it cannot detect this arcing and sparking that's occurring, and that can start an electrical fire. And that would just persist unless he had an AFCI on the circuit. Now this is an example of you'll notice I just turned that blue handle on, which is the thermomagnetic circuit breaker. This is the Guillotine test I told you about. And in this case here, we're basically have an SPT2 cord, and we just tease it, and we can do that all day long, and it won't trip. And you'll see that light on this breaker does not go away. Hold on. There's your thermomag breaker. There's the light. It's showing you it is still on. It is not tripping with this sparking. And every time I turn on that breaker, I have the light is on. This is the SPT2 cord down here basically going in. And this is the guillotine. That's the blade. And I'm teasing that circuit. And that is what we call a parallel arc because I'm cutting across the conductor. I'm cutting across the conductor. It's a hot and a neutral. Now I'm going to show you a series arc. So this is a standard, one of the standard tests, and I'm in series with the load. I'm at 5 amps, and I'm going to. You basically have a carbon post, and you have a copper post, and you create this arc, and this is on a standard thermomagnetic circuit breaker, and it is not tripping. It will continue until it causes a fire. This is not detectable by a thermomagnetic circuit breaker. Now, this technology is available on 15 and 20 amp circuits at this time because that's where the code has been has basically placed the requirements. But as you can see, this is it's not a high energy, it's very low energy, and it can start a fire. Now, what we have shown is we can show. I could show you that even below 5 amps, you could probably start a fire. But it's not as it's much more difficult to detect without nuisance tripping. So that's basically what you saw there was a series and parallel arc, and you have the detection. Now here's the technology that you have inside of a circuit breaker. You'll see this has two sets of, there's a few sets of, two sets of donuts in here. This here is not a donut, that is a coil, that's a trip circuit. That's basically what, when you tell a breaker to trip from the brain, you know, it activates this coil right here. But here is your load terminal that goes out to the load. This is where you're neutral, so you have hot and you have neutral. You'll notice that this conductor, just like in a GFCI, this terminal comes down and goes through the donut. It goes through this donut too. There's two of them in series. It goes in through, now that's basically what the electronics is looking at. It comes down through this area, and this is what we call the thermomagnetic circuit breaker. So you have a thermal element here and a magnetic element. Comes down through here, and then you see this little rope here? That rope is your it's a flexible cord, but that is what gets you to the contact. And this breaker is open right now, but when this closes, that completes your circuit. So if you follow the journey of the electron through this breaker, it comes from the utility in here through the contacts, up through this rope, in through the bimetal. Remember, in a thermomagnetic circuit breaker, you're going to have two metals that basically, you're going to have two dissimilar metals. I got to slow down a little bit. My discussion here, I'm getting excited. I got two dissimilar metals that when you heat them up, that portion of this circuit bends. And when it bends, it will, to a certain point, it will drop a lever and it will trip the breaker. And that's your thermal capability. The magnetic capability is when you put a very high fault current through here, you'll pull this, I call it the clapper. If my engineering team was on here, they would just put their head down and go, what did we do? But I call it the clapper, but it's a magnetic, the magnetic forces basically suck this little plate in and it trips it instantaneously. So the electrons flow through that element, through this little black conductor, down through this current transformer, and then through this current transformer, and then out to the load. That's the journey of the electron through this device. Now, if you were doing a thermography, I've gotten some questions on this. They'll say, we put a thermal camera on your circuit breaker, and we noticed that the temperature is very high on the front of this breaker, and they want to know why. Well, and they'll say, well, that's a bad thing. Well, it's not a bad thing, because when current is flowing, you have a couple points in here. This little rope can get a little bit warm. And then if you look right across the face, look what's coming down right across the face inside of this breaker. You have the conductor that's got to go through this CT, and look at its proximity to the front of that breaker. This conductor is going to get a little warm. And if you're doing a thermal test, a scan, you'll not just see the face of this breaker. You're going to see what's heating it directly behind that face. And unfortunately, that conductor is right in front of that face, and we've, moved some design since the picture of this has been taken. So, we rerouted some of the conductors internally so that we didn't have that same complaint. But we didn't change much other than change where the conductor is routed in this device. But in any case, that's basically the insides of a AFCI device, and everything on that side of the device is your standard thermomagnetic circuit breaker. Everything on this side of the device is your electronic brain. So that little board inside, this board that's right in here that has the current transformers, that big blue thing, this big blue thing right here is a metal oxide varistor. That's an MOV that gives us some surge protection to protect the electronics. And so that's basically what you see in there. Now, the other thing to remember when you wire these in, you better land that pigtail. It's just like a GFCI. If you don't land the pigtail, you've got a very expensive thermomagnetic circuit breaker. So you've got to land that pigtail. Now, for the most part, I know Eaton was an innovator back in the branch feeder days, and we came out with a plug-on neutral circuit breaker. It was popular. It wasn't as popular as it is today because expansion of AFCIs leaves that panel board with a lot of AFCIs. So those pigtails get kind of busy in the trough. But now I think, I'm not sure how many manufacturers offer a plug-on neutral. I know we do from an Eaton perspective. And the plug-on neutral gets rid of the pigtails and cleans up the trough and makes a nice clean installation. You can't make a mistake because you're plugging onto the neutral. You forget to land that, then you have a very expensive thermomagnetic circuit breaker. Before we get into why AFCIs, I am going to take a look at the chat because I have been negligent in looking at chat. So I don't see anything going on YouTube. We've got 117 people out there watching right now. Thank you for tuning in on YouTube. Let's take a look. Boy, the chats are going. Okay, let's take a look on WebEx chats. I sure remember that famous picture. Yep, good morning. This is from early, never ever so erratic. You just set the bar for next week. We saw all those total. Okay, we're scrolling down. I believe airlines. Oh, I remember that discussion. That was early. Selective coordination for GFCI, Article 517. Yeah, GFPE. You're right, Jeff. Selective coordination for ground fault protection of equipment. I had this thought a while back, Class A and SP special cert purpose. Yep, I'm here and signed in. We got our local 98 boys. Excellent. New York, thank you for joining. Or from York, PA. I'm sorry, that's the home of Harley Davidson, right? I got my Harley. I haven't ridden it in a while. The Menti number missed the last 2 digits. There's the Menti number. Thanks for sharing things. You guys are awesome. I think you sent out the 331 certificates only. No, I did send out yesterday. So Mr. Moore, send me an email. You should be on that list. I remember you there. I didn't receive a certificate. If you didn't receive a certificate, please send me an email. And I'll double check the spreadsheet, but I'm just driving off of the spreadsheet. We are still not getting out there, Tom. Remember that combination came into being with the combination series and parallel protection. Sorry, we went over the series and parallel thing. Didn't even have an AFCI GFCI in the branch feeder. Yes, we did. So we had an AFCI GFCI device back in the branch feeder days of the business. So we did have that back in the day. And you know what, we didn't sell that many of those, I don't believe, because where they used them was primarily when you had a bedroom and you had an outside receptacle that was off of that bedroom, and they would just buy an AFCI GFCI device. But since the expansion of AFCIs in the areas where you see GFCIs, we're seeing a lot more AFGF devices go out the door. So if it's not combination type, does it only detect series or only detect parallel faults? If it's not a combination type, the only thing you get, again, on the combination type is that you get the series arc protection in an SBT2 cord. You get series arc detection in the home run in an NM wire, but you just don't get it in an SBT2 cord. All right, this is how the UL guide card required them to be marked: circuit breaker, GFCI, combination AFCI, or circuit breaker. So thank you, Mr. Facteau, in the chat session. You know what I'm going to do is I'm going to just try something here. I'm going to copy that. I'm going to go out to YouTube. And this is paste. Excellent. See, I can even chat on YouTube. That's phenomenal. All right, so I just copied that, Jeff, out to the YouTube people who don't have the pleasure of seeing our chat session on WebEx. Why does that dual-purpose AFCI have a pigtail and also a terminal for the load neutral? Good question. So if you think about an AFCI and a GFCI circuit breaker are unique in that you have to land both the hot and the neutral. And in the diagram that we went through showing the internals of an AFCI, I showed the journey of that conductor. You've got to get both the hot and neutral through the donut. That's a critical part of the pie. That's why that's in. And then we had the open mic issue. Not as loud, poor audio as well. Not as good as yesterday. I can hear you, but a little bit low. That was at 12:13. Boy, I'm really going back there. Plug on neutral. Tom, it extends both parallel and... Oh, no, we covered that one. Okay. But branch feeder, AFCI got obsoleted. The branch feeder, there, I know we were selling them in Canada. I believe Canada still had some provisions for that. I don't know if Nihad can speak to that one at all, if you can chat that one out. But you're probably right that the branch feeder is not something that you can get anymore. It was NEC 2002, not 2003. Oh, did I say 2003? It's the 2002 NEC. Also, an effective date, January 1st, 2002. Yes. So, just to be clear, the answer is false, but if you do have an SPT2, the AFCI will only protect it in certain cases, but not all. Referring to the slide about types of tests on the SPT. That is correct. If you have an SPT2 cord and you have an AFCI, if it was the branch feeder, if you have an older device, then you'll have parallel arc detection, not the series arc detection. Now, here's an important thing. Even an AFCI is not going to protect you if you misapply extension cords and whatnot. If for example, you have an extension cord, you run it under a rug, and you're misapplying that extension cord, you could heat the insulation up. You could cause a fire because you've misapplied that product. If you had a glowing connection, a glowing arc connection is not something that is detectable by an AFCI as well. Jeff Fecteau says, I'm going to put this out there to my YouTube buddies. Good point, Jeff. I'm going to put this out. Jeff says, post, I hit the arrow. AFCI for fire alarms is not prohibited. It's just not required. That is a very good point. It's you do have an exception. If you don't want to put it on there, you don't have to. But if you wanted to put it on there, it's not telling you that you can't. So hopefully, trying to chat that out. Right. It says GE claims to have an AFCI that can be used with shared neutrals. Well, everybody does if it's a 2-pole. If it's a single pole, they may have listed that. You got to make sure that the rating is 120/240. If it's not 120/240, then you can't. For some reason, I can't post that last one. All right. Arrow down. I'm doing more questions. At least one brand. Shared neutrals, yep. Branch feeder AFCI to be able to provide series protection for grounding conductors. How it detects an arc. Okay, so let's talk about, can I explain the working principle of an AFCI, how it detects an arc? So, let's think about this. How can I describe it? Remember we had current transformers that, we had current transformers inside that device, and there's a microprocessor. So we're sampling the sine wave, the waveform, and I'm looking at the waveform, and I am looking for abnormal events. I'm looking for shoulders on my sine wave. So let me do this. Let's. Oh, if I I have video of this, but I'm going to try something here. Say I have a sine wave, and I have a nice sine wave looks like this, right? If I have a problem on my sine wave, I could have noise. Noise will ride on the sine wave like this. I don't want to trip on that. There are good arcs and there are bad arcs. Noise is not bad. And you're seeing a couple CTs inside because I'm doing ground fault detection in some cases, and I might be looking at different frequencies as well. So when you see an arc that has some shoulders like this, I'm going to call them shoulders, and you'll have all kinds of ugly looking waveforms and spikes in there going on. I'm looking at a signature of a waveform inside that little AFCI device. I mean, that is just fantastic if you think about it from a technology perspective. I can look and sample a waveform. I'm not looking at RMS anymore. I'm looking at 60 hertz. I'm looking at higher frequencies, and I might be, depending upon the algorithms, which are all proprietary information, I might be looking at various frequencies and looking for abnormal signatures at one frequency, an abnormal signature at a very higher frequency. So I'm doing a lot with regard to looking for a signature of that AC sine wave that is not considered a normal arc. And then I need to detect that and then trip. Now, the challenge with this is when you get some solutions, like I know back in the day when AFCIs first hit the market, dimmer switches. If you would look at the signature of a dimmer switch, whenever you turn that thing up and down, especially if you do it really fast, they were the most horrible looking signatures. And did they look like arcing? Absolutely. And that's the challenge of the design engineer for AFCIs and with all the different manufacturers. We have to figure out what is a good arc and what is a bad arc. And we found and we learned that some of the products were violating FCC regulations. And when that occurs, I mean, you have I liken it to a dirty pond, and you have a nice, good fish. You have the most beautiful goldfish. It's the greatest goldfish, but it dies inside of a dirty pond because you've got all these products out there that are violating FCC regulations. They're putting a lot of noise on the system, and we're trying to, we work with appliance manufacturers. We work with other people when we find those areas. And we tried to put some code requirements in that address the FCC regulations, but for the most part, we've made a better goldfish, in my opinion. Okay, so let's go down. I'm going through some more questions. It appears that both hot and neutral go through the second CT. Yes, I thought started. Nope, you thought wrong. Eaton had the first plug-on neutral back in the day in the branch feeder days. Yep. Siemens officially launched. Okay, excellent. So Siemens. So there are multiple manufacturers cutting those pigtails off. So that's a good thing. That is a good thing. All right, I'm gonna type in my my email address. I'm gonna say domitrovich@eaton.com. So you have that. Okay, 7:40. So I'm just looking through some of the text. All right, so here we go. I sent that to Nihad. Forget about it. Do it later. Let's continue on with our regularly scheduled program. Here we go. Why AFCIs? Now, this is something that I looked at, this discussion point I looked at a long time ago, and I realized that there are basically, in my opinion, there are three phases of a structure. You have the construction phase. And if you think about the construction phase of a residential home, you've got about 50 to 75 junction boxes and switches. Depends upon the size of the structure, obviously, but you've got a lot of junction boxes in there and switches and outlets. You have thousands of feet of wire, and then you have the electrician whose work is supposed to come before everybody else. Well, not everybody else. I mean, you got to have 2x4s and whatnot there, but you obviously can't put wire in while the drywall's there. and the cabinets can't be mounted on the wall until the drywall gets there, and shelving is going to go up after the fact. So during the construction phase, you have multiple trades inside of a facility, inside of that, whatever it is, a house or commercial construction, whatever it is. You have a lot of different people working inside that structure. There are a lot of opportunities to damage equipment, damage conductors, and everything that we do from an electrical perspective. Now, the second area is you have the homeowner moves in. And usually what happens when a homeowner moves in? Well, I don't like those receptacles. I don't like the color. I want to change that because I'm painting the house. So do they call an electrician for that? Probably not. The most technical savvy 4-year-old in the house is probably going to be the one to replace all that. I know when I was a kid, my mom did most of the electrical work in the house. And I was the life safety crew because I watched the light switch as she installed the ceiling fan to make sure that that nobody turned the light switch on while she was up there. So you know, a lot of stuff happens inside of a home. We mount things on the wall. We put pictures on the wall. We put more shelves in, and we bring our own appliances in. So the homeowner is going to do a lot inside there. And then you have the aging of the structure. And this is all of the homeowners after the initial homeowner. This is the rodents that are going to move in. And it's not relatives, I'm talking rodents. Wire degradation due to humidity, heat, vibration, all the different things that could possibly happen in this system is going to occur as the structure ages. So let's talk about the construction. You know, you have the order of the business, the order of things on how they're done is critical. And I experienced this lack of order firsthand when I built my first house a while back, where my plumber and my HVAC guy came in after my electrical guy. When my electrical guy showed up, he's standing in the basement and he's looking up, and I couldn't figure out what was going on. I had just visited the house. He told me he was going to be there, and I always want to be there when my electrical guy's there just to chat things up a bit. And he's scratching his head. He was on the phone. He gets off. He's all upset. And I said, "What's wrong?" And he says, "Well, the plumber's not here yet, and he's not scheduled to come out, and your HVAC guy hasn't been here yet." And I'm like, "Well, so I mean, you have all this room now to install all these wires." He goes, "Well, that's a problem because I don't know where they're going to put their stuff, and I need to know that." But he did it anyway because that was just what he had to do. And so the picture that you see here is one of those areas where, you know, after he left, the HVAC guy came in and he says, "Well, these wires are in my way." So what does he do? He had a little broom handle, and he would put it up behind all those wires, and he would yank them down and then push his ductwork behind those wires. And I didn't see him doing it. I saw the broom handle, or it was a cut off broom handle, and I sort of put 2 and 2 together. So all of my, you know, he could have jeopardized those conductors. He's running it through ductwork, through the return path, and I mean, you know, there's probably lots of different things that were wrong in that installation. He pulled out the staple, which cut the conductor. You know, when you see stuff like this, you start poking your head around, and you start to realize that, well, you know, I could have a little bit more of an issue than I thought. So the order of construction is really important. But then even as an electrical professional, the goal in putting staples in is to hit the staple, right? And really, I know I used to think this, that I thought that you had to drive that staple nice and tight. In reality, you're not supposed to drive those staples, and the staples aren't supposed to have more conductors under them than you're supposed to. So this one was boogered up a little bit, not a pretty sight, but you know, this stuff happens. So that was a damaged conductor. Here's some conductors that were drawn through gusset plates, and Jeff, you might recognize some of these as well. These are conductors where they were pulled, and you had damage because of right there, you know, right where these things go together, right in these points here, there's a metal gusset plate there that when you pull that conductor through there, you can cut that conductor. You know, these areas are dangerous. You know, when you're pulling down through the system, down through your ductwork. And then there's the again, if you have ground fault upstream, GFCI, etc., this is where you're going to have some issues, possibly if you have the ground and neutral. So obviously we did a little cutaway to demonstrate this, but that's a grounded neutral on this side of the conductor. So I have my white wire landing on this side, and things can get messy in a box. And when you're pushing that receptacle back into the box, you have to make sure that you're not getting a grounded neutral inside there. So that's the construction phase. Then you have the homeowner moving in, right? So what does a homeowner do? They add ceiling fans, attic lighting. They change receptacles out. They put accent lighting in, cabinets, shelving. There's a lot of things that I call it the do-it-yourself syndrome. That is, it's what we do. It's what it's not necessarily a bad thing. You do-it-yourself syndrome is okay, but a man has to know his limitations. The AFCIs have been known to find problems. So here is a recall where about 83,750 lights are recalled, and look at the OSHA, the report that came out from the Consumer Product Safety Commission. Thomas Lighting has received 11 reports of defective fixtures with resulting in homes arc fault circuit interrupters tripping. No injuries have been reported. So the AFCIs are going to find those products that are out there that aren't performing correctly. There's a little do-it-yourself syndrome, right? I mean, that's we've seen this stuff, all of these types of installations, and I love this one here. You've got this nice SPT2 cord that's going through the door jamb. That's a misapplication of a product. You can't do that, right? So here's an existing installation, and not only didn't they drill the hole here, they put it right over. This is probably in an area where they probably weren't going to drywall it or whatnot, but this stuff is out there, and AFCIs and GFCIs are going to find those problems. Then you have the aging structure. This is a picture out of my brother's house. This is one of those areas where we had we upgraded his installation, his house for arc fault circuit interrupters, and we had some tripping on a few circuits, and this was one of those circuits. And when we took everything out, that conductor was on an outside wall. You can even see the rust inside behind that box. It wasn't very pretty whatsoever. But there's a better picture of it, and you can see how the insulation just came right off of those conductors. There's this one here was a part of an installation where they were sharing the neutral inside. This was a bathroom circuit. They were basically they wrapped. You can't really see it here, but they wrapped the neutral around the outside of this receptacle or this light switch. So there are a lot of different examples. This was a rodent that was blamed for an electrical fire. Poor rodent. He probably didn't know what he was doing, but he was just out. They love insulation. So in this case here, they evacuated. Nobody was hurt, but it caused $20,000 worth of damage. And this stuff happens. Nobody. We report the fire statistics and we report some incidents and things like that. But what used to be said and I think to an extent is still being said in some cases, where they'll say that breaker didn't do what it was supposed to do. That circuit breaker didn't protect the wires. The appliance manufacturer, they made a faulty product and that breaker should have picked it up. Well, everybody wants to blame somebody when a fire happens. And the circuit breaker manufacturers really took a brunt of that because they were being accused of their devices not doing what they were supposed to be doing, and that was an ungood thing. So, but that's how AFCIs came into the picture. So now, if you look at That's what I wanted to. So if you look at history a little bit, I love this portion. I love this slide because, you know, we went from knob and tube to BX to two conductor, then we had aluminum bonding strip inside, and then we came into what we know throughout the years. But did you know that in the National Electrical Code, there was an expansion of the three-prong receptacle, the grounded receptacles? We always had no ground, you know, two-prong, you know, hot and neutral type of deal on receptacles, but there was a progression of adding that equipment grounding conductor. They started in the laundry room, and then they went to basements, garages, and outdoors, and then they expanded to the rest of the home. So that simple equipment grounding conductor saw an expansion in the NEC, and now here we are at AFCIs and GFCIs, and the technology progressed through history to include a brain inside of a receptacle even. Now let's talk a little bit about success stories. I just heard somebody on the thing, so make sure you're muted. Don't want to have to kick you out. This was a case example of a house in South Carolina where an electrician, and there's a series of videos associated with this on my YouTube channel. There's like 4 or 5 parts where we have the homeowner explaining what he was going through. But what you're seeing is, and I'll just tell you this story briefly here. The conductors, the electrician unknowingly drilled through a gusset plate that came from the home run circuit that went from the panel board up to the first outlet inside of the bedroom. And they drilled through the gusset plate, and when he pulled the conductor through, it stripped all that wire and caused a lot of issues with damaging the home run circuit. And so what was happening, it was periodically tripping for the homeowner. It was like once a month. They would have a trip. He'd have to go down and reset the breaker, and he was frustrated with it. He had his electrician out a couple times, and the electrician, the first one, came out and said, "Oh, you need Super Duty industrial light switches and receptacles." So, you know, the homeowner said, "Well, okay, you know, replace them." So he replaced all the receptacles, and he still had the tripping issues. And then that guy didn't call him back, and then the next guy calls him back and comes to visit the house, and he says, "Oh, no," he says, "you just need, I don't know, you need to ring out this circuit and do something." I mean, he sold him something else and tried to fix it, and then he started to get people tell him, "Well, just replace that with a thermomagnetic breaker." And the homeowner didn't want to do that because he said he's selling a house, and if he's selling that house, he knows it's going to get a home inspection, and he doesn't want the home inspector to basically give him a hassle and say, "Hey, this needs to be AFCI protected because it's the bedroom circuit." So he had the electrician. He said, "No, I don't want this." So he got frustrated and he called our 800 number, which I'm going to take you out to that NEMA site here in a second to show you where those resources are for you. He called the 800 number. He got a hold of Joe Fellow, and Joe Fellow basically walked him through. The guy was an engineer who worked in an organization. Joe walked him through some basic troubleshooting, and they identified that it was the home run circuit. So he calls his electrician, the first electrician that was apparently went to the hospital, and then he got out of the hospital, and he came back to help him out. And through the guidance of Joe, they worked through, and he found this problem. And the electrician said, "This is it gives me goosebumps when I talk about it." He says he went up into the attic, and the first thing he smelled was gas. And he says, "You know, I'm not a plumber." He says, "But I used to do plumbing work." He says, "I knew how to take soapy water and put it on the gas fittings up there." And he found, I think, 2 or 3 leaks in the attic near the area where this arcing was going on. So he tightened up those fittings, let it air out. Then he started looking at the circuit, and he found where they drilled through the gusset plate. He tried, and what you're seeing in the image there, is the tape that he used. So that is right over there in that image. He tried to put tape, and the homeowner said, "You know what? Listen, can you just pull another circuit?" And the electrician says, "Yeah, I can do that." So he did. He pulled another circuit pulled another home run circuit, and got that circuit back up and running again, and they sent the pictures. I got a really great letter from the homeowner thanking us, and in his eyes, he saved his family, and he saved the next family's life, which I can't say whether he did or didn't, but this prompted me, because I was a member of the NEMA AFCI task group that was going on, and I went to the other manufacturers and I said, you know, we talk about fires and we talk about the problems, but we don't talk about the found problems and the success stories that we have, and that we should be talking about more of. So we created a NEMA success story web document and a PowerPoint presentation. And what I'm going to do is take you to the NEMA website, because I want you to understand what this resource is for you, since we're talking about when you may have a problem or you may have a tripping issue that you're trying to troubleshoot. The manufacturers of AFCIs got together under the envelope of NEMA, the National Electrical Manufacturers Association, and they created resources for the industry. We have obviously the UL training course, which I talked about earlier. We have the state adoption. We have white papers, and in the white paper document, you'll see the history of the AFCI. That was a Siemens document. We have the arc fault circuit interrupters preventing electrical fires from ESFIs. This takes you out to their website. Okay, and it shows you resources that they have. And Electrical Safety Foundation International is another great resource for you, and especially if you're an electrician, to help the electricians or help your homeowners understand. We have fast facts, unwanted tripping reporting. So if you have tripping going on in a job site, and you want help from one of the 4 manufacturers of the circuit breakers, you can put your name, last name. You can provide information, provide the manufacturer of the brand of AFCIs, whether or not it's a 15 or 20 amp circuit, the breaker type, whether it's a 2-pole or a single pole. You can upload a breaker image if you want to. If you wanted to upload a video file, so, you know, we all have phones, we have smartphones, we can take little videos. I mean, heck, I'm streaming on YouTube, for goodness sakes, and I'm in my basement. So there's a bunch of stuff that you can do technically to get enough information, and provide this. Even if you're talking to the homeowner and they give you this information, you can share this with the manufacturer. The manufacturer will contact you back and get back to you with that some guidance on how to troubleshoot that. There's unwanted tripping reports for the homeowner perspective. There's news and there's multimedia. I'm looking for a specific thing. There's some videos out here for us. Here's presentations on the arc fault circuit interrupter success stories. And I have to share this with you because I think that you will hopefully enjoy seeing some of these, because we talk too much about what the negative things that happened. I want to talk more about the positive thing. So here's what you can download off of NEMA. To get rid of that, but let's walk down through here. So this one is a disaster. This was the South Carolina, the first story. You know why it's the first story? Because when this hit the street, I went down to those guys and I said, we need to start educating about found problems and the successes that we have, because there are a lot of them out there. We just don't talk about them enough. So this was the one that we just talked about. There's the same 2 pictures. Here is a homeowner built a house in 2004. And it's the garage door started tripping in 2014. Wiring failure in a light on the left side of the garage caused the AFCI to start tripping. Problem averted. This was a pull pump and saltwater generator that pulls about 14 amps. A teen must have plugged a cord to mow the lawn, but reconnected with another 25 extension cord. This was detected by an AFCI. This was faulty wiring that was inside of a. Is that on? That's like inside of the panel board, because that looks like a breaker in there. That was found. Here's another good one. This was AFCI was tripping on a microwave circuit. They weren't sure what was going on, but look what happened. They now, who's to say who came before or after that I'm sure the electrician didn't just stuff it under there. Probably somebody after the fact came in and put a hanger in and just went right over the wire. And that was above a duct. Not a duck, not a quack quack, it was a duct. So, home built in 1979 in Hampton Township. Homeowner chose a significant renovation, upgraded the electrical service, and they put AFCIs in, and bam. Now, you think about it. The home was in there since '79. All of a sudden, I upgraded my service, and now these AFCIs are tripping. What are they going to do? They're going to blame the AFCI. But our troubleshooting skills have to be good to be able to find those problems. Without the AFCIs, the faulty wiring may not have been discovered for some time, and this was in Alabama, almost a year old. The cable was part of a three-way switch loop. Look what happened to that cable. It was damaged in the attic when the staple was driven too tight. This is, you know, sometimes wearing glasses when you're stapling conductors is important. Wear your glasses. Now, some people will say, well, all you need to do is use an insulated staple. Well, that'll solve all your problems. Well, no, they won't, because you got to hit the staple, right? So in this case, the cable sheath was removed, and the hammer, you can see the hammer marks on the cable. So the type of staple that you use doesn't really matter, because you're still driving those staples with hammers, and we still have trouble hitting the mark, right? This was, again, a NIC conductor. You can see it right there. Piercing was caused, and that's on the neutral side of the business. There's a light fixture. The contractor says, my wife and I are very lucky that I stumbled into the problem after we were away and a fire had started. Had a fire started, we could have lost the house or worse. So this was an upgrade. They upgraded the existing home. So now you can upgrade existing homes, and you may have tripping issues, but please don't just ignore the tripping issues, because these devices are tripping for a reason. And it's the old homes that help contribute to the fire statistics that made the requirement for these in the first place. So these are all examples, and it's a free download off of the internet. So the next thing I want to do is it's 1:49. I am going to take a look real quick at the NEC requirements again. I can find my my screen. So let's come back over here to the National Electrical Code, and let's take a look at some of this language. Hopefully it's not too small on your screens, so that I can increase this. But you notice that you have, this is the 2020 National Electrical Code. We haven't seen expansion over the last two cycles, so it's the same thing if you're on the 17 code. You have kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, rec rooms. These are all the rooms. And you have these options. You could have a listed combination type AFCI, which we already talked about, so you know exactly what a listed combination type AFCI is, and that is the circuit breaker installed at the in the panel board. You have a listed branch feeder type AFCI, and you already know what that is, at the origin, and you can have the outlet type branch circuit device installed at the first outlet, and it can't, so that provides the complete protection. And remember that the OBC device is going to give you the series arc detection downstream that you so want and need. And then your third and fourth items. So the listed supplemental arc protection breaker doesn't exist. There's not a UL standard for it. You really can't do 3 yet. A lot of people say, well, why is it in there? Well, yeah, it's been in there for a few cycles. Nobody is asked to take it out. There's no listed product that will meet 3. A listed outlet branch circuit type arc fault circuit interrupter installed at the first outlet on the branch circuit in combination with a listed branch circuit overcurrent protective device where all of the following conditions are met. You have to have a continuous run to the first outlet. It can't be longer than 50 foot if it's a 14, a 70 foot if it's a 12. And it has to hit the first outlet, and it has to be marked that that's the first outlet. And then it has to have a combination of the branch circuit overcurrent device, which is the standard thermal mag breaker or some breaker that would be able to provide the level of protection that's needed for that home run circuit, and the outlet branch circuit AFCI downstream. So those two work together. There is a product on the market. Eaton has a solution on the market where we have an OBC AFCI that's packaged together with a combination type or not a combination type AFCI. It's a thermomagnetic circuit breaker. There is some electronics inside that, I believe, that will provide the protection that's necessary for that first home run circuit, and then you get complete protection. That's been an important thing to provide complete protection in item 4. So you need a listed pair of devices, which Eaton does have a solution for that one. I believe we're the only ones who have that solution. But in any case, then you could also include it in metal raceway, auxiliary gutters. So if you protect that home run circuit from the items like nails and things of that nature, then you're going to provide protection to be able to just have that instead of having the AFCI for that first outlet. And then you can put the OBC AFCI at that first outlet. And there's no length restriction on that either. And then we're a listed metal or non-metallic conduit. So if you're using, like Chicago uses conduit. If you're running that conduit down to the first outlet, you can put an OBC AFCI with a standard thermomagnetic circuit breaker at the source. There's the exception we already talked about. There's some informational notes that helps you understand all that. There was a new requirement in dormitory units. I think that was in the 17 cycle. So you have 15 and 20 amp branch circuits that supply dormitory unit bedrooms, living rooms, hallways, closets, and bathrooms, etc. You have to have one of those options. We added this in the 2020 code: patient sleeping rooms, guest suites, in nursing homes and limited care facilities. That was added in the 2020 cycle. Before it was just guest rooms and suites. And again, it's hotels and motels and patient sleeping rooms in nursing homes. So it's the sleeping rooms and guest rooms in the hotels and motels. So that's more of a commercial, less of a residential. Branch circuit extensions. This was an exception that was given. So if you are modifying, this was really, we put this in place because there was a concern about not like deterring people from upgrading their services. So they said if you upgrade your service or you move your service from one spot to another, or you move a sub panel less than so many feet and 6 foot is that area, then you don't have to provide the AFCI protection for that circuit. So we provided some, and we could argue, I already made the statement that existing homes are a part of the issue, but yet we're given an exception so you don't have to put AFCIs in existing homes if you're not modifying the circuit all that much. But in any case, we did give you some relaxation in the AFCI requirements for existing dwelling units and dormitory units and guest rooms and suites. So that's basically the 210.12. You've got A, B, C, and D. B is your dormitory units, C is your guest rooms, and D is your extensions or modifications, and this gives you exceptions. And there's also one and 4.0 in your receptacles. So let's just do a search for AFCI, how that works. Yeah, there's a lot of errors being made in I believe it's for some reason that's not finding it for me. Oh, I know why. Just taking a little time. Now watch, I'm gonna kill my feed. Right. Searching, I shouldn't have done that. Try to delete that. Clear search results. I'm gonna clear it and just navigate to it. Just grab my book while that's doing it. But if you go back to chapter 4 inside the NEC, if you go to 4.0, I believe it is 406. I think it's 406. 406.4. Now remember, 406 is receptacles. Receptacles Rating and type 406 is receptacles, cord connectors, and attachment plugs. And 406.4, I believe, is the section that we're going to want to look at. 4 is general installation requirements. And D is replacements. So 406.4D is replacements. Take that off while we go through that. I want to have everybody looking at my internet sitting there spinning. So 406.4D4 is the item that you're going to look at, and that says replacement of receptacles shall comply with 406.4D1 through D7. And if you go to 406.4D, bing, bada boom, bada bang, 4 arc fault circuit interrupters, it says if a receptacle outlet located in any areas specified in A, B, or C, 210.12 A, B, or C, so those are your areas that we've talked about already. That's your your living room, your kitchen, your den, all that good stuff. You either have to have one of the following: a listed outlet branch circuit type AFCI receptacle, a receptacle protected by a listed outlet branch circuit type arc fault circuit interrupter type receptacle, that's the OBC, or you have to have a receptacle protected by a listed combination type arc fault circuit interrupter type circuit breaker. So you could have you could put an AFCI if you're replacing a receptacle in one of those areas in a residential home, in an existing home, then you're going to have to either put an OBC AFCI in that circuit, or put a combination type AFCI circuit breaker at the source. And it says that 210.12D, remember that exception we talked about for existing homes? That does not apply. So even though there is an exception that if you're not modifying that circuit and you're not moving things around more than 6 foot, etc., that doesn't apply to when you're replacing receptacles. So if you're in your bedroom and AFCIs are required in the bedroom circuits, and you're going to replace the receptacle in that room, then you're going to have an OBC AFCI in there, or you're going to have to replace it, put a circuit breaker upstream. So that is 406.4D4, and apparently I just didn't know how to search on NFPA. Thank you, Mr. Fecteau. I got to be in that article chapter to start searching. I was searching in the wrong spot. So hopefully, if NFPA is out there, I love that PDF, but we have other solutions. So in any case, let's talk. I think we are at 2 o'clock, and that was, I believe, my last. I believe that was my last slide anyway. So I am going to flash up the quiz for those who are online taking that are interested in the PDH credits and causing my evening to be erratic, trying to get those things made. Please go to menti.com, enter 794901, and you'll be able to take the short little quiz. And I know everybody is going to ace it. And while you're doing that, I'm going to look at some of these questions. I'm going to look on my online. I haven't been watching my stream. I don't know why I can't. Oh, I see why. I have a limit in the number of words I can put in that stream. So you clarify a bit more about 120-volt smoke detector where AFCI is required. So smoke alarms, you're required to have smoke alarm. You're required to have smoke alarms in a residential home. But some of the discussion has been in the past, well, I don't want to put my smoke alarms on an AFCI protected circuit because I don't want, if it trips, then I don't have my smoke alarm. You're still required to, unless there's a local jurisdiction law that says you're not allowed to, or you're not permitted to, or something like that. I would highly recommend. There's no compatibility issues, but your smoke alarm in your residential homes are going to need to be AFCI protected as well. I'm not sure how much more to elaborate on that one. The YouTube. Okay. see what else. We've got Jeff. Thank you very much, Jeff, for all of your input, and you too, David. Yeah, we have the YouTube video of Joe Fellow with that customer. It's on my YouTube site, www.youtube.com/C as in Charlie/Thomas Dimitrovich, and the whole series is on there. You gotta check that out, David. David Engelhardt, Joe Fecta. I'm just looking through some of the questions. Would short circuit protection protect against parallel arc from hot to neutral? So here's the issue with that is the length of the conductor. So when you look at a residential home, a lot of these homes are put in locations where the available fault current from the utility is not very high. If you have a lot of fault current, you could get probably a lot of current arcing that's done if you go hot to neutral. It depends on where you're at in the circuit. And how far away from the service and what's the source. There are a lot of different variables. What the instantaneous is on a molded case circuit breaker, those vary considerably. There are so many variables on whether or not that molded case circuit breaker A is going to have an instantaneous, B, what is it set to? UL 49 does not require, you got to come to my circuit breaker basics class, which I'm going to have next week. I haven't put the notice out for that. I believe it's going to be on Thursday afternoon. It's not going to be 12 to 2. I'm going to see if I can make it 12 to 2, but yeah, that one's still out there. But you have to understand molded case circuit breakers to really understand why you can't rely on that thing to give you arcing fault detection. Okay, it looks like everybody, I've got all the questions. It looks like we went through all of the chats. I appreciate everybody's dialogue in the chat, and I don't know how many people we had online, but I know we had a lot of people online. We still have a lot of people online. They're tailing off a little bit, so get that code. And I think that that all of that is pretty good. So I want to thank everybody for dialing in. I want to thank everybody on YouTube. I really appreciate it, that your dedication to electrical safety is up there with mine. I find it very important. We save lives together, and our knowledge is really critical. And social distancing is really critical today. And I know a lot of us are working remotely. So thank you for spending 2 hours with me today to talk about AFCIs, and hopefully I will see you tomorrow. We're going to talk about electrical safe work practices. We're going to understand arc flash. We're going to understand those limitations around when is it considered a shock hazard and when it's not considered a shock hazard. We'll talk about different things like that tomorrow, maybe a little bit about the overcurrent devices. And then next week, NEC code changes 2020. One of those days out of the 5 is going to be on breaker basics. I'm still working out my schedule on Thursday. I think I have a customer presentation to do. But if I don't, it will be 12 to 2. If I do, it'll probably be either before 12 to 2 for 2 hours, sometime in the morning or sometime in the afternoon. I will. You'll see some emails from me on that. Thank you very much for tuning in. So stay safe and remember to AFCI protect everything, right? And GFCI protect everything. All right, we're going to sign off, and we're going to close up shop. Take care. Good night. Goodbye. Shut the feed down next. So those on YouTube, I'm going to shut you down. Thanks we have 91 people on there now, 90 people on there still watching. And we did good. Shut the feed down first.